Hi, this video is on ionic bonding. In this video, you'll learn what ions are, why they form, and what ionic bonding is. Now, most elements don't exist as single atoms. Some exist as simple molecules, and others form giant lattice structures. And the reason for this is that the universe tends towards stability, and atoms are no different. They also tend towards stability. And one type of atomic stability is when the electrons are stable. Now, electrons occupy energy levels around the nucleus, and the electrons can arrange themselves in different ways in these energy levels, and we call these electronic configurations. Now, the electronic configurations that have the least energy are going to be the most stable. In a previous video, I drew out the electronic structures of the first 18 elements, and I'm just going to do another example just to recap how the electrons will fill in and why this leads to stability. So we'll take the example of calcium, which has atomic number 20, so that means it's got 20 protons, 20 electrons. It's in period 4, group 2. So it's in period 4, and so I automatically know it's going to have 4 energy levels, which we draw circles like this. And now we need to start filling in the electrons, the 20 electrons. The first 2 electrons will occupy the first energy level, the one closest to the nucleus, and a maximum of 2 electrons can occupy that energy level. So then we fill in the second energy level, and a maximum of 8 electrons can fill that energy level. And then we move on to the next energy level, and a maximum of 8 can occupy the third energy level. So now we've completely filled 3 energy levels, and we've got 18 electrons. So the last 2 electrons now occupy that outer energy level. And we know it's going to have 2 outer shell electrons because it's in group 2. Its electronic configuration is 2882. Now, why is this stabilizing? Well, the first energy level has the least energy, the second has the second least energy, the third has the third least energy, and the fourth has the highest energy. That's the outer shell electron. So the way I've filled in those electrons, that electronic configuration of 2882 is the most stable electronic configuration of the calcium atom. Now, some electronic configurations are more stabilizing than others. For example, having a full outer shell of electrons is stabilizing, and this is what drives reactivity, the ability to have a full outer shell of electrons. Now, let's look at the periodic table and see which elements already have a full outer shell electrons. They're those on the right hand side, that group 8, known as the noble gases. Yeah, these have a full outer shell of electrons, so they are very stable, and so they exist as atoms because they are so unreactive. Now, the rest of the elements from group 1 all the way to group 7 don't have full outer shell of electrons. Group 1 elements will have 1 outer shell electron, group 2 elements will have 2, group 3 will have 3, and so forth. But not to worry, because something can be done about this. These elements can gain full energy levels. So we'll take the example of a group 1 element. So from group 1, we'll take the example of sodium. Now, sodium has atomic number 11. So what could the sodium atom do to gain a full outer shell? That's what we're looking at. So sodium is symbol Na, and it's in group 1, and just drawing the outer shell electrons. So it will only have one electron in its outer shell. We'll still have to draw the electronic configuration, write the electronic configuration. So it's in period 3, group 1. So we'll have full first energy level 2, full second energy level 8, and 1 in its outer shell. 281 is its electronic configuration. Well, what could the sodium atom do? Well, it could lose 1 electron. When it loses that electron, a new particle is formed, and this new particle, again, just drawing the outer shell electrons, will have this energy level empty, and it will have electronic configuration of 28. So if you notice, that outer shell is full. Now we need to count the charges on the particles, and the charges come from the protons and the neutrons. So in the atom, sodium atom, will have 11 positive charges from the 11 protons and 11 negative charges from the 11 electrons, and taking away the negative charges from the positive. So remember, 11 take away 11 will give you a charge of 0, so the sodium atom is neutral. Now doing the same for this new particle here, well, we will still have 11 positive charges because we have lost a proton, but this time we will have 10 negative charges. We lost an electron, and taking the negative away from the positive, 11 take away 10, we get a charge of +1. So this new particle is known as an ion because it's a charged particle, and it's got a charge of +1, which we write in the top right hand corner in square brackets. Now to recap, sodium atom has lost 1 electron to form the sodium ion, which has a charge of +1, and its electronic configuration is 2,8, and that means it's stable. It's got a full outer shell, and it has a noble gas configuration of neon, so it's unreactive. Now let's take the example of a group 7 element. So from group 7 we'll take the example of chlorine. Chlorine has atomic number 17. So it's got atomic number 17. Now it's in period 3, just like sodium and group 7. And again, just drawing the outer shell electrons. Here, chlorine will have 7 outer shell electrons because it's in group 7. So drawing those outer shell electrons, 1, 2, 3, 4, 5, 6, 7. Its electronic configuration will be 2 because it's got full first energy level, 8, 7. Now, what could happen to the chlorine atom? Well, the easiest thing that could happen is that one electron could be donated to the chlorine atom, or chlorine could gain 1 electron and a new particle will form, and this new particle, now just drawing the outer shell, will have 7 electrons that were originally from the chlorine atom, and it will have an 8th electron that has been donated. So its electronic configuration will be 2, 8, 8. So notice it's got a full outer shell of electrons. That's what we wanted. Now counting the charges again. So in the chlorine atom, we will have 17 positive charges from the protons and 17 negative charges from the electrons. So 17 take away 17 will give you a charge of 0. And counting the charges on this new particle, well, it will have 17 positive charges from the 17 protons, because we haven't gained a proton or lost a proton. But this time we will have 18 negative charges. So 17 take away 18 will give you a charge of -1. So this charged particle is known as an ion because it's charged, and it will have a -1 charge, which you draw in square brackets like this and put the charge in the top right hand corner. Now the electronic configuration is that of noble gas argon, which means it's stable and unreactive. So to recap, an electron has been donated to the chlorine atom to form the chloride ion. Now we need to look at where that electron has come from. There needs to be a species that donates that electron. Well, sodium could donate that electron, so a reaction could happen where sodium donates an electron or transfers an electron to the chlorine atom to form the chloride ion. So to recap, a transfer of an electron from the sodium atom to the chlorine atom occurs here in this reaction. So it has to be in the presence. So chlorine in the presence of sodium will gain an electron, and we get new products formed. We'll get the positively charged sodium ion formed, which are known as cations, and we will have negatively charged chloride ions formed, and negatively charged chloride ions are known as anions. So the anion and the cation will combine to form a new product known as sodium chloride with the formula NaCl. So let's go to a group 2 element, another example, and this time we'll take the example of magnesium. It's just next to sodium in the periodic table, and it has atomic number 12. It symbol Mg, and it's in period 3, just like in sodium, and it's in group 2. So just drawing the outer shell electrons, well, magnesium will have 2 outer shell electrons because it's in group 2, and its electronic structure will be 2, 8, 2. So what could happen to magnesium to gain a full outer shell? Well, magnesium will have to lose not 1 but 2 electrons. So 2 electrons will have to be lost from the magnesium atom to form a new particle. And this particle will have the outer shell empty, and this electronic configuration will be 2, 8. Now let's look at the charges, count the charges. So the positive and negative charges. Well, magnesium atom will have 12 positive charges from the 12 protons, 12 negative charges from the 12 electrons. So if you take away the negative from the positive, you get a charge of 0. So the magnesium atom will be 0. Next, we'll look at the charges on the ion. So we'll have 12 positive charges from the 12 protons, but this time we'll only have 10 negative charges because we've lost 2 electrons. So 12, the negative charges take away the positive charges, 12 take away 10, would give you a charge of +2. So this is an ion now. Magnesium ion is formed because it's a charged particle with a +2 charge, which you draw in square brackets and write the charge in the corner. Now, the configuration has a noble gas configuration of neon, so that means it's stable and very unreactive. So to recap, the magnesium atom has lost 2 electrons to form the magnesium ion, which has a 2+ charge. Now let's take the example of a group 7 element. Fluorine has atomic number 9, so it's in period 2 and group 7. Just drawing the outer shell electrons again, it will have 7 outer shell electrons because it's in group 7. 1, 2, 3, 4, 5, 6, 7, and its electronic configuration will be 2, 7. Now, just like fluorine could gain 1 electron, or 1 electron could be donated to the fluorine atom, and when that happens, we get a new particle that's formed, and this new particle will have a full outer shell of electrons, 7 from the fluorine atom originally, and the 8th one that has been just donated to it. So we'll have a full outer shell. Electronic configuration will be 2, 8, and this electronic configuration is the same as the noble gas neon again, and that means it's going to be very stable and unreactive. So counting the charges again, on the fluorine atom, we'll have 9 positive charges from the 9 protons, 9 negative charges from the 9 electrons. So 9 take away 9 will give you a charge of 0. So the fluorine atom will be neutral. And look at the fluoride ion. We will have 9 positive charges from the 9 protons, but we'll have 10 negative charges from the 10 electrons. 9 take away 10 will give you a charge of -1. So this fluoride ion will have be negative -1 charge if you draw like that. So where has the electron come from? Well, the electron could come from the magnesium atom. So magnesium could donate or transfer one of its electrons to the fluorine atom to form a fluoride ion. But magnesium not just doesn't lose 1 electron, but loses 2 electrons. So what happens to the second electron? Well, that second electron can be donated to a different fluorine atom, which we can draw out again, or we can write like this: 2 fluorine atoms will become 2 fluoride ions. So to summarize what has happened in this reaction, so fluorine in the presence of a magnesium, 2 electrons from a magnesium atom are transferred to 2 different fluorine atoms to form fluoride ions. Now the new product that's formed when magnesium reacts with fluorine has a formula MgF2, magnesium fluoride. So why do we have the formula MgF2? Well, Magnesium has a +2 charge, so you need two negative charge fluoride ions to balance out the +2 charge of magnesium.